All right, guys, let's go over this really quickly here. All right, so going step by step here, I wanted you guys to convert these to SI units to start. So this is 10 micron, which is 10 times 10 to the negative 6 power meters, and this is 2.5 micron. Same thing, 2.5 times 10 to the negative 6. Basically, we do that and we get 1 times 10 to the negative 5th and 2.5 times 10 to the negative 6, like I just said. And that's because the 0 went away, why it's to the negative 5th. All right, and then I wanted us to convert micrograms per cubic meter into kilograms per cubic meter. And what we get when we do that is over here under our mass. So we're basically just converting the kilograms. I get 5 times 10 to the negative 7th, which makes sense because we're just moving the decimal over 9 times, and 4.1 times 10 to the negative 7th. Problem 2 specifically states that a person breathes in half of a cubic meter of air, so it's only half of one of these. And so what I did is I just took those values and I cut them in half, and we get 2.5 times 10 to the negative 7th and 2.05 times 10 to the negative 7th. So a very, very, very small mass in kilograms. And then question 3 asks for you to find the volume of the volume of an individual these individual particles. And so we get 1 times 10 to the negative 5th power is the diameter. And so what we need to do is divide that by 2 to get the radius, and then do the same thing with this, 2.5 times 10 to the 6. So you're going to use those radiuses, you're going to cube them and multiply them by 4/3 pi. So 4/3 pi r cubed, and that gives you a volume, a very tiny volume, because it is just a very small piece of a cubic meter, right? 5.24 10 to the negative 16, 8.18 times 10 to the negative 18th power cubic meters. And then question 4 gets a little trickier. It asks for you to find, let me get the wording right here, the volume of particles an adult breathes in an hour. Okay, so we have the mass they breathe, and we have the mass in an hour, and then I gave you the mass of an individual particle. Now this is very much a rough estimate, but if you find, you will find though, if you double or half or cut into even 1/10 of the size or 10 times the size of those particles, the final answer isn't going to change by any noticeable amount. Well, I guess maybe by 10 times it might, but it's these numbers don't change a lot because they're so tiny. Anyway, so what I did is, you see down here, 332 parts per hour, 272 parts per hour. That's by taking this and dividing by the mass, the accepted mass of a dust or smoke particle, which is 7.53 times 10 to the negative 10 power. And like I said, that's just a very rough estimate. Just like with gases, scientists kind of just give it they say, they're all about this size. And even though they have different volumes, kind of dramatically different volumes, we all estimate them to be very, very lightweight. And that might throw our answer off a little bit, but not enough that's even noticeable, you'll find. Okay, so by doing that division, you get 332 particles per hour of the 10 micron and 272 particles per hour of the 2.5 micron. And then as we move over here, we get, what I did here is I took the individual particles now, and the question was what was the volume. And so what I did is I multiplied the volume of a single particle by the total number of particles to get us the total volume of particles that we breathe in an hour for both sets, for the 10 micron and the 2.5 micron. You add them together and you get almost the same number, because this smaller particle almost adds nothing to the number. I think it increases this by 2. So instead of 1.74 now, it's 1.76. All right, next question is, okay, well, how long would I have to breathe to collect 1 teaspoon of these particles, 1 volume of a teaspoon, in my lungs? And that's if my lungs collected all of it, which it does collect quite a bit. Your lungs are pretty sticky. They're designed to be that way, to stop things from passing to your bloodstream. Unfortunately, there's a lot of toxins in here, and they do pass to your bloodstream, and that's the point that we're going to be making here. What you find is it takes about 28 million hours, right? So what I did to find that is I took this value, right? I took the volume of a teaspoon in cubic meters, 4.92892, that's probably a little too far to go, but times 10 to the negative 6 meters. And I figured out basically how many of those, that's how many per hour, goes into a teaspoon, and that gives you about, actually my calculator, oddly enough, by just doing this, literally gave me exactly 28 million. I think my calculator was probably rounding. These numbers are starting to get too tiny, that's why. So 28 million hours, or about 3,200 years, to get about a teaspoon of this in your lungs. Which says a lot about what's actually happening when you breathe in smoke. The smoke isn't literally suffocating you. You're not sucking in smoke and it's causing you to choke to death because you can't get air. What's actually happening is this very, 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 very fine amount of material, even for 1 hour, is enough to cause gagging, watering of eyes, irritation to nose. It's the chemical reaction of the touching of the particles to the little hair-like material that's inside of your lungs, nose, and everything else. And so it obviously does not take very much. Anyway, these numbers I just picked off of that website like we talked about. If you were in the middle of the fire, this number is actually closer to about 1,200. And at one point we were at 800, but you're going to find that this number is not going to change, and this number is not going to change very dramatically. But it only takes a very small amount, as you can see. Anyway, there's that. I'm going to add an extension of this for extra credit. I'm going to have somebody look up what is the, well, I'll explain it in the assignment. Don't worry about it on this video. Anyway, there's my solution. If it is incorrect, if you find something that's incorrect, let me know. I'll go back and fix it. Obviously, I just ran through this quickly myself, and this room actually has some smoke in it as well, so I'm having a little trouble thinking because my throat hurts. Anyway, I'm going to head home. Send me a message if you have any more questions. Mr. McLeod out.